Hello, everyone, and welcome to our presentation for our manufacturing processes class. I'm Sevil Begum Gürcan, and we are excited to present our project, Manufacturing Processes of a Stapler, an everyday object we all use but rarely think about, the classic office stapler.
Hi, I am Harun Ulukaya and we will walking you through the components, manufacturing techniques, and materials behind staplers.
And I'm Soeda Ercan. Let's dive into mechanics and hidden engineering that brings this simple tool to life.
First of all, let's start with the question, what is a stapler? A stapler is a mechanical device used to fasten sheets of paper and bind them together. It works by driving a metal staple through the paper and folding the legs to hold it in place. Though simple in appearance, it is made of carefully designed and manufactured components.
Now, what does a stapler do? Staplers come in different types, manual, electric, or heavy duty, and are commonly used in offices, schools, and homes. Despite differences in design, the purpose remains the same, organizing papers in a neat and secure way.
Stapler consists of several parts: the handle, base, hammer, magazine, pusher, anvil, crimp area, spring, pin, throat, and staplers. Each one has a role in overall mechanism, contributing to how smoothly the tool operates.
We group these 11 key components that will be explained further, including how they're manufactured, which materials are used, and their specific functions.
Now let's go through each component with a video.
These are the parts of a stapler. This is the handle.
Which applies force comfortably,
This is the base.
which stabilizes the stapler,
This is the anvil.
the base support for bending,
This is the crimp area.
where staple legs are bent,
This is the pin.
a pivot that links moving parts,
These are the staples.
Pierce and fasten the paper.
This is the pusher.
Feeds each staple.
This is the spring. This is
which resets the mechanism,
the magazine.
Stores the
And
staples.
here is the throat.
Is where paper is inserted.
The hammer.
And last, drives the staple downward.
And those are the parts of a stapler.
Let's go to the details.
Let's go to the details. The hammer is the internal metal part that strikes the staple, forcing it through the paper. It must deliver consistent impact force and resist wear over time.
the throat is the opening where you insert the paper before stapling. Its size determines how deep the staple can reach into the sheet stack.
The magazine in the compartment that holds the staples before they are used. It ensures the staples are properly lined up for smooth feeding.
The pusher keeps the staples under pressure, pushing them forward one by one. It works by using a spring mechanism for continuous operation.
Staples are small metal listeners that pierce and bind paper together. They are loaded into the magazine in preformed strips.
The crimp area is where the staple legs are bent after they pass through the paper. This helps lock the papers together securely without tearing them.
The anvil is a firm metal plate that supports the staple legs during crimping. It helps hold the legs inward, create a tight grip.
The base is the bottom platform that supports all stapler components. It keeps the staplers steady while paper is being stapled.
The pin is a small connector that holds moving parts in alignment. It acts like a pivot, allowing the handle and the hammer to operate properly.
The spring helps reset the stapler after each press and powers the pusher. It allows continuous smooth operation by storing and releasing tension.
Handle is the part you press to operate the stapler. It designed for easy grip and applies force to activate the stapling mechanism.
This technical drawing gives an internal look at the full stapler mechanism. It shows how parts align and work together, highlighting the clever engineering behind such a simple tool.
Staplers involve various manufacturing techniques: injection molding for plastic parts, stamping and forming for metal parts, wire drawing and heat treatment for durability, surface finishing for protection and visual appeal.
And one of the key parts of manufacturing processes is the injection molding part. Injection molding is used to produce the plastic parts of a stapler, such as the handle, pusher, and base cover. The material commonly used here is ABS, a type of thermoplastic. Thermoplastics are materials that soften when heated and harden when cooled, which makes them ideal for molding into precise shapes. ABS specifically is chosen because it combines toughness, rigidity, and a smooth surface finish, which is important for both the functionality and the appearance of the stapler parts.
Metal components like the base and the magazine are made using stamping and forming. These process shape sheet metal into precise, stable forms through the use of dies and presses.
Wire drawing and heat treatment. Wire drawing reduces wire diameter while increasing strength, essential for staples and springs. Heat treatment is used to harden parts like the driver blade and springs, ensuring they remain strong and elastic through repeated use.
Surface treatments like painting, zinc plating, or coatings prevent rust and improve durability. These finishing touches also enhance the stapler's appearance and resistance to wear.
Now it's time for a video to think of the processes clearer. Here we can see the metal parts even better and imagine in our heads. Here are some of the components, the materials we chose, and the functions of them, which we already explained before. And here we can see the BOM table, which is the bill of materials table we see in our lecture 2 lab in the manufacturing processes class.
The staples themselves are manufactured through wire drawing, precision cutting, bending, and coating. Zinc or resin coatings reduce jamming and protect against corrosion. Materials like galvanized steel or stainless steel are common depending on the environment.
Here is a CAD graphic of a stapler. We found it and it is listed in our references. In modern manufacturing, CAD or computer-aided design plays a big role. Engineers use CAD software to model, test, and refine stapler designs before production. It ensures parts are strong, ergonomic, and fit together perfectly. This reduces errors, improves efficiency, and helps visualize the final product in 3D. and helps us understand the parts and components better.
And finally, staplers are everywhere. In offices, they help bind reports and organize files. In schools, they keep assignments and worksheets together. In packaging, heavy-duty staplers are seal boxes. In printing, they bind booklets or brochures.
There was a thank you slide. So thank you for listening us and watching our presentation. We hope this gave you a deeper appreciation of how everyday objects like staplers are designed and built with precision, planning, and a lot more complexity than meets the eye.
Thanks for listening,
Thanks
guys.
for listening.